Okay, so we're doing the back side of the notes from yesterday. So you should have the back side out, ready to go. Today's going to be a little bit difficult, so you're going to have to follow along. I'm going to go through 6 of these problems, and you're going to need to do the other 6. You're going to do the odds, I'm going to do the evens. So you need to follow along, really pay attention. Fractions can be difficult. There's going to be a little quiz on this probably tomorrow, and I really want everybody to do well on it. So let's go ahead and dig into this and see if we can get through this thing. So now we're dealing with fractions. Fractions in rational equations. And rational, again, just means equations or numbers that are either fractions or decimals. That's pretty much the main thing you need to know. And it doesn't really change anything. Everything is still done the same way and according to all the same rules we've already learned. So let's take a look at number 14. Number 14, first thing we do, where's the variable? Well, the variable's right here, okay? You don't need to underline it, but there it is. What are we doing to the variable? We're adding 2 2/3 to it, okay? So we need to subtract 2 2/3. Now, the best strategy here, and I think this is going to probably work on all of these problems, is turn them into improper fractions. So if you remember, multiply, add. And this one, we're going to need to get a common denominator. So first, let's figure out what our improper fraction is. And it's obviously going to be a 3 in the denominator. So let's go ahead and do that. I'm going to go ahead and put my equal sign because I'm going to need the whole equation rewritten with the improper fraction. 3 times 2 is 6, plus 2 is 8. So we end up with 8/3 plus a on the right. And then 3, I need to turn that into an improper fraction. Well, yeah, it would be an improper fraction with the same denominator as the 8/3. So I need a 3 below that, but I don't just stick a 3 because if I put a 3 below 3, I end up with 1. So what does 3 go into 3 times? And if you think about it, 9/3, right? Because 9 divided by 3 is 3. So there we go. We're good with that. So now we've got an equation written with fractions that all have common denominators. So now all we got to do, subtract 8/3 from both sides. Because this is a positive 8/3. When we're adding and subtracting, we're just doing the opposite of adding and subtracting. We're not just changing signs, we're adding and subtracting and doing the opposite to undo what's being done. So if I have 8/3 and I take away 8/3, that goes away. And remember, you need your equal bar below it all the time except when you're multiplying and dividing. Multiplying and dividing is a little bit different. We're not doing that yet. And I also need, remember, my teeter-totter or my seesaw. I need to do the same exact thing on both sides of the equal sign, the left and the right. Well, what's 9 minus 8? That's 1, and the third stays. So A equals 1/3. Okay? So let's check it. And I think the simplest way to check it is using the improper fraction. So over here's our check stuff. We're going to check our equation over here, and I'm going to keep it with the improper fractions because this is going to be an easier way to fix it or to check it. So I rewrote it with this equation instead, so it'll be a little simpler. And now I'm going to rewrite it again and get rid of my variable and put in what I think the answer is. Okay, A is 1/3. That's what we got over here on the left. Well, and again, notice that 9/3 on the left has not changed. It should not change. The sign should not just suddenly change when you're checking stuff. Don't change the sign just to make things match. Again, that's not how math works. 8/3 plus 1/3, guess what? That's 9/3. So it doesn't matter. I could go ahead and make it into, make it correct and 3 equals 3, doesn't matter. Both of these match. Okay, so I know 1/3 is my answer over here. Okay. Again, let's do that again on number 16. So I'll move down here to 16. Now, again, let's make everything into common denominator. Well, let's make improper fractions. Let's do that first. So we want to get rid of our whole numbers. So this 1 is a whole number. We got to get rid of that. So let's do this again. X minus 2/5 equals, and remember, multiply and add. 7 times 1 is 7, plus 3 is 10. So it gives me 10/7. So now I got to come up with a common denominator. And the simplest way to figure out a common denominator is multiply your two denominators together. So 5 times 7 gives me 35, and I can't think of a number smaller than that both 5 and 7 go into. So I guess I'm going to go with 35. So we need to put 7 over 7 and 5 over 5, because we have to multiply by, basically what we're multiplying by is 1. What's 7 divided by 7? 1. What's 5 divided by 5? It's 1. I'm just doing that so we have a common denominator. It changes the numbers but not the value. So we have x minus 14/35 is equal to 50/35. Now we have something we can kind of work on. So again, we look at the variable. The variable's x. What's being done to x? We're subtracting 14/35. So how do we get rid of a negative 14/35? We add 14/35. Okay? And we do the same thing over here. Always do it to opposite sides of the equal sign. Don't do the same operation to one side 2 times. It's not the way we do it. So these cancel. Positive and negative cancel. So we get x equals 50 plus 14. That is 64/35. And double sure here. Yeah. And what we end up with, we know 35 goes into 64 one time. And once we take 35 out, we end up with 29/35 left. And I don't think that reduces. I don't know of anything that goes into 29 and 35 evenly. So I think that's our answer. So now we need to check it. So let's go back up here. And again, I'm gonna use the equation here where I already came up with a common denominator. So as long as I did everything right before that, I should be good. So x minus 14/35 is equal to 50/35. Now I take out the x, I put in I substitute in what I thought was the answer. I'm going to use the improper fraction form. 64/35 minus 14/35 equals 50/35. And now I can just get rid of those parentheses if I want, or I can just go ahead and do the math. The parentheses are really there to kind of separate things. Sometimes they're there to show multiplication. Sometimes they're just to show, okay, here's something I want to focus on. So let's look at this. 60. We got a common denominator, so it doesn't matter. So 64 minus 14, guess what that is? 50/35 is equal to 50/35. So that's cool. We can even reduce it if we want. So it gives me 1 and 15/35. And this is something you might want to think about doing whenever you're doing a math problem. A lot of times they won't take an improper fraction as an answer. And what number goes into 15 and 35 evenly? That would be 5. So that gives me 1 3/7 equals 1 3/7. Okay, so all those match, obviously. But as long as they match, that means our answer over here was good. Okay. Now, next part. One thing we got to remember. Recall, to divide by a fraction, multiply by its reciprocal. That just means remember, keep, change, flip. You keep the first fraction, you change division to multiplication, and you flip the second fraction. So I'll show you what I'm talking about. So here we are on number 18. 18. Half x is equal to negative 17/8. So what is being done to the variable? We see the variables on the left. I always deal with the stuff on the side with the variable, always. If there's something with the variable, a number or a rational number, which is a decimal or a fraction, we have to get rid of that. We want the variable by itself, okay? So that 1/2 next to the x, like I said, whenever there's a number next to a letter, it's always multiplication. So that's multiplication. So I need to divide by 1/2. So I'm going to do this. Okay? Looks kind of weird, I know, but that's why I kind of made the division bar really big. Remember, this is the division bar right here. Okay? So it's 1/2 divided by 1/2. Well, what's 1/2 divided by 1/2? How many times does 1/2 go into 1/2? One time. So again, that's why we do this. When we multiply and divide, we're looking for a giant 1. So that leaves me with just x on the left. And what they were talking about right here, I got negative 17/18 divided by 1/2. I'm going to do my work down here. Negative 17/18 divided by 1/2. I'm going to go ahead and do this. That is equal to negative 17/18. Keep, change division to multiplication, flip. And now I can multiply straight across. Negative 17, and actually let's do this. Let's reduce. Remember cross-reducing and all of the other stuff? 17/18 I can't reduce. 2 over 1 I can't reduce. 17 and 1 I cannot reduce, but 18 and 2 I can. 2 goes into 2 once. 2 goes into 18 9 times. Now we've got something a little simpler to deal with. 17 times 1, that's negative 17 over 9. 9 times 1 is 9. So we end up with negative 17 over 9, or how many times does 9 go into 17? The negative stays up front, 1 and 8/9. So we have an answer. Let's plug that into our equation. So I'm going to go over here, I'm going to rewrite my equation. 1/2 x is equal to negative 17/18. I'm going to redo it again. I'm going to take out x, put in parentheses, and I'm going to put in my improper fraction here because that's simpler to deal with, so I don't have to turn it back in. If I use the proper fraction, the negative 1, or the mixed numbers, negative 1 and 8/9, I'll just have to turn it back into an improper fraction. So it's easier just to leave it in here as an improper fraction. Now, we know this is a positive 1/2 times a negative 17/9, so that we know that's going to be a negative answer. Multiply straight across. 1 times 17, 17. 2 times 9 is 18. Well, guess what? Checks out. So that tells me either one of these answers is right. I would say try to focus on making your answer into a mixed number if you have a improper fraction. Just makes things a lot simpler for everybody. It looks cleaner, looks better. Okay? So that's that problem. Let's go on to number 20. So number 20 is weird. I'll give you that. I'm going to rewrite it so maybe it makes a little more sense. Okay? Negative 15 over 21 is equal to, and this is the same thing, 3/7, oops, not m, sorry, n. Same thing. Okay, now we look at this, it's a little bit simpler to understand now. And all we got to do is divide by 3/7 again. Okay? So, if we divide by 3/7, that becomes a big 1. So we end up with n. And then we need to divide by 3/7 here. Now again, remember, if we do negative 15 over 21 divided by 3/7 is the same as negative 15 over 21 times, keep, change, flip. So 15, well, let's see if we can do some reduction. Cool. 15 over 2 I can't reduce. 7 over 3 I can't reduce. 2 and 7 can't reduce. 15 and 3, cool. 3 goes into 3 one time, 3 goes into 15 5 times. So now we got something a little simpler to deal with. Negative 5 times 7, now we just multiply straight across. That's a negative 5 times 7, gives me negative 35. 2 times 1 is 2. Okay, so now we know we have negative 35 halves. And we can simplify that. We can also say it's, let me move some stuff. Hopefully you really need to make sure you give everything as much room as you can on some of these things. 2 goes into 35. Let's see, it's 15, 17 times. So it's negative 17 and a half is n. So either one of those is the answer. Let's double check it though. Let's use our improper fractions, because using the improper fractions is always easier when we check. So I'm rewriting the exact same equation we started out with, and now you can kind of just write it the way it was. It won't be a, no, actually let's write it the way we used it. Maybe make it, it'll be easier. Okay, so we got negative 15 over 21 is equal to 3/7 times negative 35 over 2. So then we still have negative 15 over 21 is equal to, let's see if we got some stuff we can reduce. 3 over 7 can't reduce, 35 over 2 we can't reduce, the 3 and the 2 cross-reduce, can't do that, but the 7 and the 35 we can cross-reduce, because 7 goes into 7 once, 7 goes into 35 5. So now we got something a little bit simpler to deal with. So I'm looking at one thing here where I messed up. Boom, because I was seeing this 1 times 2 wasn't working out. I kept getting a 2 here, and I was like, that's not going to work, because I know the top is negative 15. I looked back over here, and I had left that 21 times 1. This should have been 21. So hopefully maybe you caught it too, but luckily it didn't mess us totally up. But this should have been a 21 right here, right? So 1 times 21 gives us the 21 here. So now we know that's right, and we know our answers check out. So forgive my pause, but I was noticing I made a mistake somewhere. That's why you don't just make things match, because I knew there was a problem when I kept coming up with just a 2 here. So I had to go back and look, why do I have just a 2? Well, because I didn't carry right there that 21 down there. I didn't put the 1 down. I just missed one little number, and my whole thing was messed up. Okay? So that's why it's very important to check and to not just switch stuff the last second, because that means your answer is going to be wrong. Okay? Don't just stick a 21 on. Now, in this case, if I had just stuck a 21 in there, yeah, but I needed to go back and see why was I coming up with the wrong answer. And that was all because this right here should have been a 21 and not a 2. Okay. So, and those can also, they could be reduced if you really wanted to, because 3 goes into both of them. So 3 goes into 15 5 times, 3 goes into 21 7 times. So same thing, still checks out. Okay, because this could have reduced, but we'll leave it alone. So let's look at number 22. 22 is pretty easy. Okay, this was basically a straight ahead inverse operation, because we look at where's the variable. The variable's on the right. It's n. What's being done to n? It's being divided by 2. Remember, this means division. Okay, n divided by 2. So how do we get rid of division? What's the opposite of division? We multiply by 2. So we just put a 2 in parentheses up here in the numerator. We put a 2 over here by our whole number. Guess what? That becomes a big 1, so we end up with just n over here. What's 2 times 1? 2. Okay, that's pretty simple. Hopefully it checks out. Let's redo it. Let's check it. N divided by 2, 1 is equal to 2 divided by 2, 1 is equal to 1. Cool, so that means n is equal to 2. We're good. Not a difficult problem. Let's look at 24. So, we have got negative 2m, or negative 2 times m. Remember, a number next to a letter is always multiplication, is equal to 15 halves. This shouldn't be a terribly difficult problem for you. We've got negative 2 times m. So how do we get rid of that? Well, there's a couple of ways we can do it. I kind of like to do it this way. Divide by negative 2, divide by negative 2. Now, if I'm dividing a fraction by negative 2, I'd make that a negative 2 over 1. So then this becomes 1m, so we have m is equal to, and now we have, and I'm going to do my work down here, 15 over 2 divided by negative 2 over 1 is the same as 15 over 2 times, keep, change, flip. Now I can just cross multiply, or just not cross multiply, straight across multiply. 5 times 1, 15 times 1, 15. 2 times negative 2 is negative 4. Okay, so now let's check it. We got an answer. So we get negative 15 over 4, or we get, how many times 4 go in there? It goes negative 3 and 3/4, I believe. 12, 13, 14, 15, yeah, negative 3 and 3/4. But we're going to use the improper fraction to check. So let's check. Negative 2m is equal to 15 over 2. Negative 2 times negative 15, that's a negative 15, got to be careful. Negative 15 over 4 is equal to 15 halves. Now this, I can just do this. Now I can just multiply straight across. Negative times a negative is a positive. 2 times 15 is 30. Put a line under it. 1 times 4 is 4. Well, are they equal? Well, let's see. Does anything go into 30 and 4 that would give me the 15 and the 2? Yeah, 2. 2 goes into 30 15 times. 2 goes into 4 2 times. So guess what? Checks out. So these would be my answers. Okay. You are responsible for the odds on the back of this page. 13, 15, 17, 19, 21, and 23. Those need to be done. 13, 15, 17, 19, 21, and 23. And I'll probably just have you do the odds on the rest of the homework. It should be on the board. Whatever I write on the board for the homework is what you're responsible for, but I'm pretty sure it's just going to be the odds for the rest of the homework. Okay? And that is it for today.